All right, so there's two ways to draw the negatives, right? One is negative angle, so negative 61. Everything starts on the right-hand side over here. I can go clockwise instead of counterclockwise. If I go clockwise, then this would be negative 90. So I know it's got to be in between that 0 and negative 90, and it's going to be a little bit closer. So it's an approximation, doesn't have to be exact, but I would say it's like that. That's one way to do the negative angles. The other way to do the negative angles is to draw them as though they are positive and then fold your graph along the x-axis. So a positive 61 is going to be around here, and then I would fold it in half and it would overlap, and then that makes that the negative angle. So you can do either way. I would say the bigger the angle, the harder it is to do the fold, but it doesn't really matter. Like if it's more than 360, it might be more complicated.
Can I show you that?
Yeah. So today's section is 5.3. 5.2, sorry. It's called Trig Functions. So we're going to go a little bit further into like what trig is and what to do with it, okay? So we start with if I was to draw an angle in my circle and then close it in and make a triangle, we actually form a right triangle. So if you remember from geometry, SOHCAHTOA, that magical little acronym, right? Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. All of this basically can be overlapped with that. So if I were to take an angle, let's just say I grab the first one because this is in the first quadrant. I take an angle, so here's my x-axis, my y-axis, whatever degree measurement this is, okay? We would be saying this is less than 90 if it's in the first quadrant. I can take the end point of that. Radius is the same thing as the angle at the terminal side of the angle. So if I were to close this in, I make it a right triangle where the x is going to be my adjacent side, the y is going to be my opposite side, and the r, which is referred to as the radius, is your hypotenuse. So you can take those sides and you can use SOHCAHTOA to find sine, cosine, tangent. So that's what all of this is. Sine is opposite. So if we remember opposite, hang on, let me write out the word. If we remember sine is SOH, that's opposite over hypotenuse. So if I draw out my triangle, I would go opposite, which is the y, over the hypotenuse, which is r. That's where that comes from. Then I would go to cosine, and cosine is adjacent over hypotenuse. Adjacent would be the x over the hypotenuse, which would be r. And then tangent, so that's sine, and then tangent would be y over x, or opposite over adjacent. And that's the TOA part of SOHCAHTOA. Hopefully, like those at least seem familiar, right? Those all came from geometry. But what is new for most of us, if not all of us, is the reciprocal functions of those. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So if you look at what's there, it's literally just those flipped. So if it was cosecant, so the whole word is cosecant, like that, the abbreviation is CSE. Okay, cosecant would be the reciprocal of sine, or hypotenuse over opposite. Secant, which is SECANT, which is abbreviated as SEC. That secant is the reciprocal of cosine. So you would do adjacent over hypotenuse, or hypotenuse over adjacent. And then cotangent, which is abbreviated as COT, that would be the reciprocal of tangent. So instead of it being opposite over adjacent, it becomes adjacent over opposite. These little x equals 0, y equals 0, x equals 0 just means that whatever's in the denominator can't be 0. If it's 0, then that whole thing is undefined. And you will actually you'll find some of these values to be undefined. So an undefined might pop up as an answer. So there's two ways to look at it. One is remember the y over r, the x over r, the y over x. The other is just to remember SOHCAHTOA, which would be my advice, because you're going to do these in and outside of that circle. You're going to eventually get to right triangle trig, in which we're creating right triangles outside the circle, okay? But you want to definitely know the relationships between them. The S and the C never go together, if that helps remember the secant and the cosecant. Like if I look, secant goes with cosecant, and then cosine goes with secant. The S and the C's never go together. And then cotangent and tangent, the word is literally in there, so hopefully that helps you remember. So now if I move my triangle back around my circle, let's look at, this would be in quadrant 2. If I move left and up, then my angle, even though this is the measure of the angle, I create it with this. It's called a reference angle, but I create it with that angle. And then the x is going to be negative and the y is going to be positive because I'm moving left, but I'm moving up. The r is always positive. So the hypotenuse will always be positive. But the x and the y are going to be positive or negative depending on the quadrant it's in. If I move into the third quadrant, I make my triangle look like this. I use the x-axis, the terminal side of the angle. So even though that full angle is technically what formed this triangle, when we use something called a reference angle. For inside, we use that smaller right triangle. Now I'd have a negative x and I'd have a negative y because I move left and I move down, but the r is still positive.
So the r is positive?
Always, 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 always. So r, which is the hypotenuse, always positive. And then the last one moves into the fourth quadrant. So this time I'd be moving to the right and I'd be moving down. I'd have a positive x and a negative y, and again, a positive r. And then my triangle would go in that little quadrant. So it always goes like wherever the terminal side of your triangle is, you always use that with the x-axis to make these triangles. I would never make a triangle in here. That would never be the right triangle I use. I always make the triangle with the x-axis. And then you're going to be asked some of these, okay? So number 1 says the terminal side of angle theta in standard position passes through the point 815. Find the 6 trig values of theta. So I'm a visual person. I like to draw it out. You don't have to. You might get accustomed to doing this in your head, but I would certainly recommend at least when we start, you get yourself a picture. So if the terminal point or the terminal side is at that point, passes through 815, my x would be 8, so the horizontal change would be 8. The y would be 15. Obviously, that's not drawn to scale. It doesn't have to be. Otherwise, the 15 should be almost double that length. And then I close it in with the r. Theta goes in the little angle formed by the x-axis and the terminal side of my triangle, of my angle, sorry. So now in order to find all 6, right now I have opposite and adjacent. That would get me tangent and cotangent. But to find the other ones, I have to know what r is. On that last slide, it gave you that x squared plus y squared equals r squared. But think about where that comes from, because you don't really need to learn a new formula. It's the Pythagorean theorem, right? So if I have my x and I have my y, I can find my r using just the Pythagorean theorem, okay? So a couple of tricks here are triples. So Pythagorean triples. That you're going to see a lot would be 3, 4, 5. So if I had the 2 legs are 3 and 4, the hypotenuse is 5. If I had a leg and the hypotenuse like 4 and 5, then the missing side is 3. You don't even have to do the work on that one. 6, 8, 10 is 1. 5, 12, 13, 7, 24, 25, and 8, 15, 17. I would say those are the most common ones, the first 3 being even the most common. But these will save you some work if you learn them. Have we done those yet this year? No, right? Yeah, okay. That's when pre-calc starts to blend in with algebra 2. These don't go away anytime soon. So based on that knowledge, we just saved ourselves some work, right? Because what's the hypotenuse of this question? 17. If you don't know it, you do 8 squared plus 15 squared. It's 289, which is a yucky number, but that is 17 squared. And there's no other way to find that because it's prime. Like 17 is prime, so you can't even break it down. This, no. Yeah. All right, so now I got to find the 6 trig functions. So I need to find the sine of theta, the cosine of theta, the tangent of theta, the cosecant of theta, the secant of theta, and the cotangent of theta. Now, this was in the first quadrant, so nothing was negative. All of these are going to be positive, but obviously we're going to start to pay attention to that as we move around. So sine is opposite over hypotenuse, which would be 15 over 17. Cosine is adjacent over hypotenuse, which would be 8 over 17. And tangent is opposite over adjacent, which is 15 over 8. Yep.
Do we need to simplify these?
If they can be simplified, yes, but you don't have to change them from improper. And now I just flip them. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent.
So it's just the opposite.
Just flip them. Okay, go to 2. So 2 says the terminal side of an angle theta in standard position passes through the point -3, -4. Find the 6 trig values. So standard position means it would start over here, right? But I don't always need that to use my triangle. What I really want to do is just go to this coordinate point. -3, -4 tells me I'm moving left 3 and down 4. So my angle goes from the terminal side there to the x-axis. So although this full thing would technically be theta, we only use the little sliver. It's called a reference angle. We're going to learn more about them later. But we only use that little sliver that connects the terminal side to the x-axis. What's my hypotenuse? 5. And it's positive, right? Because hypotenuse is always positive, or radius is always positive. Sine is opposite of the theta. So opposite would be -4. Hypotenuse is 5. Cosine adjacent, -3 over 5. Tangent, -4 over -3, which becomes 4/3. And then we just flip them all. -5/4, -5/3, and 3/4. All right, now we use our quadrant angles. So we kind of will flip-flop the entire time we're talking about trig, back and forth between right triangles and our circles. It's just going to happen. There is a natural overlay, okay? But you just got to think of them as two separate things, and they're going to bounce back and forth between them. Sometimes you're setting up triangles, so if there are values like 3s and 4s and that kind of stuff, obviously where they give you the side lengths, you're going to set up a triangle. Other times they're going to refer to angles, and then we go back to our circle. So this circle right here is what's called a unit circle. We are going to fill this in so much more so that you'll be so sick of it, okay? But a unit circle is based on a circle with a center at 0, 0. And a radius of 1. So that means my center is here at 0, 0, and that means I move to the right 1, up 1, left 1, down 1. Good morning. Thank you. And that's where those coordinate points come from. So if I move to the right 1, my coordinate point is 1, 0. If I move up 1, my coordinate point is 0, 1. If I move left 1, my coordinate point is -1, 0. And if I move down 1, my coordinate point is 0, -1. So that's the bare bones, right? So yesterday we did the quadrants. We did 0, 90, 180, 270, and then doubles back around to 360. Today we're putting coordinates on those. So to the right, 1, 0, up 0, 1, left -1, 0, on the bottom 0, -1. Now it's going to ask you for the sine, cosine, and tangent at these locations. So because sine would be the opposite over the radius, right? Or the y over the r. And my r is 1. What am I really looking for to find sine? If it's y over 1 every single time, what do I need? Just the y. So the sine is just the y coordinate. The cosine is going to be x over 1, which means the cosine's what? Just the x value. And the tangent is the one that's a little different because I need the opposite and the adjacent. So this is actually y over x. It's also sine over cosine, which we'll talk about in a minute. So if you think about that as you use your circle, this only works for the circle. It doesn't work for like when we have things outside, like 3/4, or if that's my side length, it doesn't work that way. This only works if you're using the unit circle. If I do that, then if I go to 90 degrees is up here, and I want to find the sine, it's what? 1. Same location, I want to find the cosine. Now it's the x there, that's 0. And then the tangent there would be the y over the x, 1 over 0, which is undefined. So now if I take those things and I flip them, I get the reciprocals, right? So what's the reciprocal of 1? 1. What's the reciprocal of 0? Undefined. If you have 0 in the top, right, it's 0. If you put it in the bottom, now it's undefined. So then what's the reciprocal of undefined? 0. Now we're going to repeat all of that, but this time we're using 180. Oh, sorry, my child. All right, so if you look at 180, right, now my x is -1, my y is 0. So the sign there would be 0. That's hard to read, sorry. The sign there would be 0. The cosine there would be -1. The tangent would be 0 over 1, which is 0. And then we flip it. So the cosecant would be undefined. The secant would stay -1. And the cotangent would be undefined. Wait, yeah. Questions? Easy stuff, right? You just got to know the location and the coordinate point, and then the rest you should be able to do. So we're going to start to do this with a lot more coordinate points. Right now we just start with that quadrant ones, and then we're going to fill in all the spaces in between. All right, so the reciprocal identities are basically the ones we already talked about, okay? This is how they rewrite them, but they are what we already know. Sine is the same thing as 1 over cosecant because cosecant is the same thing as 1 over sine. So if we have the sine, we flip it, we get the cosecant. And if we start with the cosecant, we flip it, we get the sine. We've already done this, okay? Cosine is the same thing as 1 over secant because secant is the same thing as 1 over cosine. And then tangent is 1 over cotangent, and cotangent is the same thing as 1 over sine. These are called reciprocal identities. So sometimes you'll see in instructions, use the reciprocal identities to do something, and that's what it means. Use the reciprocals, and you already know them. Use the reciprocals to get what you need. So it says cosine of theta, or find cosine of theta if secant is 5 over 3. So what's the relationship between secant and cosine? They're reciprocals. They just flip them. So cosine would be 3 over 5. Easy as that. So if it says sine and cosecant, these relationship, again, same thing, right? Reciprocal. So if the cosecant is -√6 over 2, what's the sign? -2 over √6. Can I leave it like that? No. What do we do? Good. Square root 6 and square root 6. I get -2 square root 6 over 6. One step further because this can get reduced. So -6 over √3. All right, these are some additional identities that we're going to use on the, well, I'll start on the bottom and I'll work my way up. So these are called Pythagorean identities. There's relationships between each of these kinds of trig functions when they are squared. So sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant squared. So really, like, eventually you're going to learn these, hopefully. But if you learn this first one, I will show you a trick to get to the other ones. If I know sine squared plus cosine squared equals 1, and I take and divide each of these by cosine squared, sine squared over cosine squared becomes tangent. Cosine over cosine becomes 1, and 1 over cosine would be secant. So you can get to the second one. So if you learn the first one, you can derive the other two. If I start with sine squared theta plus cosine squared theta equals 1, and I divide each of these by sine squared, this becomes sine squared over sine squared would equal 1. Cosine over sine would be cotangent. and 1 over sine would be cosecant. So order's different sometimes, like they could flip the order here or here. You could get 1 plus tangent squared equals secant squared, or cotangent squared plus 1 equals cosecant squared, but they are the same thing. So you will start to use these to solve for the other one. So just like we had the reciprocals, like if I give you cosine, you can give me secant. If I give you tangent, you should be able to give me secant. If I gave you cotangent, you should be able to give me cosecant. If I give you sine, you should be able to get to cosine without having to set up a triangle. So those are called Pythagorean identities. Again, you're going to see that in directions. It will say use Pythagorean identities to, and then you have to figure out what's missing. On the right are quotient identities, and they are simply that tangent equals sine over cosine. And cotangent is the reciprocal of that, cosine over sine. So we can use those interchangeably. The solution intervals at the top are kind of confusing when you look at it this way. But what it really means, the most important thing I would say, is that sine and cosine can never be less than -1 or bigger than 1. If you think about applying sine and cosine to triangles, and if it's bigger than 1, you're basically saying the opposite side is bigger than the hypotenuse. Can an opposite side in a right triangle be bigger than the hypotenuse? Why not? But what's the definition of a hypotenuse? The longest side. So I can never have a sine be bigger than 1 because I'm basically saying the opposite side's longer than the hypotenuse, which is supposed to be the longest side. Does that make sense? Same thing for cosine. Cosine can never be bigger than 1. And then on the reverse side, it can be never smaller than -1 for the same reason. Tangent, cotangent, secant, and cosecant can all be bigger than 1, okay? But sine and cosine cannot. That's one of the things you want to remember. So if you're ever trying to figure it out and it doesn't line up, it says sine or cosine is bigger than 1, it can't happen. All right, so this one says, and see the directions specifically say Pythagorean identities. This means sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And 1 plus cosecant squared, cotangent squared equals cosecant squared. So if, as you start to learn these, and I would say write them every time so that helps you remember them. As you start to learn them, you'll see like now, obviously sine and cosine always go together. That's like our basic foundation one. But the C's come together this time. So the cotangent and the cosecant go together, and then tangent goes with secant. Those are both like the odd ones out. But only sine and cosine are the ones that are on the same side. All right, so 5 says find sine of theta and cosine of theta if tangent of theta equals 4/3 and theta is in the third quadrant. Yuck, right? Like where do you even start? I only have a value for tangent. So I'm going to look back into my Pythagorean identities because that's what it told me to use. Which of them has tangent? Second one. So tangent squared plus 1 equals secant squared. I know tangent is 4/3. So that squared plus 1 equals secant squared. So 4/3 squared would be 16/9 plus 1. Oh my word, I keep reversing these. 16/9 plus 9/9 gives you 25/9. And that's secant squared. So if I want to solve for secant, I have to do what? Square root. So secant of theta could equal plus or minus 5/3. I don't know the sign yet. Now I need this piece of information. It's in the third quadrant. So if it's in the third quadrant, I'm moving left, which means my x is going to be negative. I'm moving down, which means my y is going to be negative. Which is why my tangent was positive, right? A negative over a negative gives you the positive. So if the x is negative, that means my cosine is going to be a negative number. If the y is negative, that means my sine is going to be a negative number. So the only thing that would be positive, if I was to find it, would be cotangent. That's what that piece of information helps you with. All right, so let's think about what we've got here. If secant is 5/3, then what do I easily get to? Cosine. Flip the 5/3, I get 3/5, and we said it's in the fourth quadrant, which means it has to be negative. You with me so far? Now, I would say there's two ways to find sine. One is you can do tangent equals sine over cosine. So I can say 4/3 equals sine, which is what I don't know, over the cosine, which is negative 3/5. And I can multiply both sides by 5/3 or negative 5/3. And I get negative 20/3. Wait, did I flip it? Hang on. Sine over cosine equals tangent. Yeah. The other way, though, let me make sure I could do both. The other way is to use what you know about that triangle. So if my tangent is 4/3, that means the opposite side is 4, and the hypotenuse is 3. Now, we said they both have to be negative, so it's negative 4 and negative 3. What would be my hypotenuse? 5. So then the cosine, or we have the cosine, sorry. The sine would be opposite, negative 4, over hypotenuse, which is 5. This is a fraction within a fraction. Right, so it would be 4/3. I think the triangle is easier. Sine, this would come to the top. So it would be 5 sine theta over negative 3. And then you'd multiply by the reciprocal, which is 3/5. And that's where you get the 4/5 from. So it was a fraction within the fraction, okay? I think the triangle's easier at that point. So you have to use the Pythagorean identity to set up the initial sides to find what's missing, but then you can use your triangle to get the other one. Let's do one more. 6 says, find cosecant if cotangent is negative 1/2 and theta is in the fourth quadrant. So first part I have is cotangent. So I would come back up to my Pythagorean identities. I grab the one that has cotangent, which is 1 plus cotangent squared equals cosecant squared. So 1 plus negative 1/2 squared would equal cosecant squared. 1 plus 1/4 equals cosecant squared. This would be 4/4, so 5/4 equals cosecant squared. And then I would square root both sides. I don't know if it's plus or minus yet. So the cosecant would be plus or minus the square root of 5 over the square root of 4, which is 2. This time, that's all I need. And it's in the fourth quadrant. So I'm moving to the right. That would be a positive x. And down, that would be a negative y. Cosecant is the reciprocal of which original function? Sine or cosine? Sine, which means I'm going to make it negative. So negative root 5 over 2. So we didn't even need to set up the triangle to find the missing side that time. It only wanted cosecant. Questions on that one?
Wait, so why would you keep it why would you keep it the same? Sorry, I was writing down.
So this time my whole equation was just cotangent and cosecant. When I solved for cosecant, that's all it asked for. If it had asked for sine, then I would flip it. So it's going to ask for different things. And I would say that's where it's confusing. Like you start to think, how do I get to sine and cosine? You want to use the first one, but I don't pick the formula based on what I'm looking for. I pick the formula based on what I have. So the one you have is how you determine which of those three identities you're going to use. Solve for whatever is the only other one. There's only going to be one other one in that equation. Solve for it, and then go back to what's asking for. This case, what I solved for was what it was asking for, so I didn't have to do anything with it. I think those are the hardest ones, by the way. All right, this one says, find the value of the 6 trig functions of an angle in standard position running through -4, 0. So this is kind of the overlap of both the things we talked about. -4, 0 is actually going to be a quadrant angle, right? Because I'm going to go 1, 2, 3, 4. So this coordinate point is here. God bless you. So I cannot make a right triangle because it's on the axis. I can't use the triangles this time. I use the x and y. So the sine is the y. My sine would be 0. The cosine is the x. This time it's -4. The tangent is the y over the x. Y is 0 over -4, which is 0. And then we flip them. Cosecant, secant, cotangent. Reciprocal of 0, undefined. Reciprocal of -4 would be -1/4. And reciprocal of 0 again, undefined. Kiara. So technically, yes. Would I mark you wrong? Probably not. You just got to remember that you're finding the sine of an angle and the cosine of an angle. Yep.
So why are you able to use like the triangle in like the first question and not here?
So if the side lengths come off the quadrants, I can make a triangle. If it's flat on my axis, I can't make a triangle. There's no, like if I went all the way over here, right? Like even if I tried to, this would be, whole thing would be theta. Normally we would make theta between not like that. Normally we would make theta between the x-axis and where I'm going, right? But I can't because it's flat. The terminal point would have to be here. So if it's on the axis, you have to use the x and y combination. If it's anywhere inside any of my quadrants, I make the right triangle.
Oh yeah, because it doesn't give you the y.
Exactly. Yep.
So how do you know if it's just not flat?
If it's got a 0 in one of your coordinates. So if the x is 0, the y is 0, you're going to be on the axis. I draw it out. For me, I like to see it. But if one of your coordinates is 0, you're on the axis. Whether the other one's positive or negative, then you're on the axis. And if it's a quadrant angle, you can't use the right triangles. All right, so this one pushes it one step further, okay? Now it's got questions that we've already answered, like the secant of 180, that kind of stuff, but then you're building it into an expression. So for now, all of these angles that you'll see inside these expressions will be quadrant angles because you know the coordinates at those quadrant angles. Eventually, we're going to move into different ones. But to answer all of these, I would draw myself my x and y axis, and I would label all the quadrants. So here's my 0 degrees. Here's my 90 degrees. Here's my 180 degrees. Here's my 270 degrees. And then this comes back around so that 360 would have the same quadrant or coordinate as 0. And then we want to label each of those points. So we're using that unit circle again where my R is 1. If I move to the right 1, this would be 1, 0, up 1, 0, 1, left 1, -1, 0, and down 1, 0, -1. So anytime it refers to an angle, you're going to use your unit circle like that. So 8 says, simplify 3 secant of 180 and 5 tangent of 360. So for secant of 180, I'm going to go to 180. Secant is the reciprocal of what? So what's the cosine at 180? Cosine's what? X or Y? Negative 1 because it's the x. What's the reciprocal of negative 1? Negative 1. So this is 3 times negative 1 minus 5, obviously stays as 5. Tangent at 360. So now I go to 360. The coordinate point there is 1, 0. Tangent is y over x. So 0 over 1 is 0. I get negative 3 minus 0, which is negative 3. Mm-hmm.
Are there situations in which you could only simplify and you don't get to an answer?
Yes, but not yet. All right, 9. Simplified tangent 360. So we just said tangent of 360 was what? No, tan of 360. 0. Good. Plus 4 times, now we want the sine at 180. So at 180, back over here again. Sine is which coordinate? That's cosine. X is cosine, sine is y, right? So what's the y at 180? 0, good. And then 2 times cosine squared of 180. So I got to figure out what the cosine is at 180 and then square it. So what's the cosine at 180? Negative 1, good. The x coordinate at 180, which would be negative 1, and then I square it. So the squared is weird on these. This cosine squared theta means get the actual cosine and then square it. So even though that squared is on the cosine, it means find the cosine of it and then square that. So I'm going to square negative 1, and that's 1. This is 0 plus 0, and this is just 2. So for right now, all of these angles should be on one of your 4 quadrants, and start labeling them. Like the more you, because we're going to keep going with these and we're going to fill in all the spots in between. The more you know those, the easier it will be moving forward. So you're, like I said, you're going to constantly throughout trig go back and forth between right triangles and your circle. The circle is all based on those angle degree measurements right now. So 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees are what you're going to see pop up. And that's your indication that you're going to use the circle. The rest of it, you're going to set up right triangles.
I was gonna ask if there's a degree ABC in a circle.
Yes. Yep. Questions? Okay, so tonight's is again a PDF. Remember, it's going to stay that way throughout the Brown Book chapter. Let me publish it.